Hello everyone. So in a previous video, we covered the meaning of a binary semaphore, which is a signal. Its code design pattern. This video, I'm going to show you how we can achieve the same effect using a queue of 1 with 0-byte payload. Again, to defer for other videos is what happens if the consumer is higher priority to consume a signal. Binary semaphore mutexes we'll cover in other videos. So I have the skeleton set up from a previous video, and I'm going to replace this with a queue of 1 item. So I need to include queue.h. Instead of a semaphore handle type, I'm going to do queue handle type, and I'm still going to call it binary semaphore. Because this video is how can I achieve the same effect using a queue of 1 item. X semaphore give is going to become X queue send. Okay. X semaphore take is going to become X queue receive. And instead of creating the binary semaphore like that, we're gonna essentially we're emulating the binary semaphore using Q API, right? So XQ create. Parameters are very important. What is the queue length? Meaning how many items does it absorb? So it has to be 1 because binary semaphore is a signal, and because of the word binary, either something is there or it's not. So there's only 1 item deep. The second parameter usage is a little creative one, and it is 0. I'm saying I want a queue, but I don't want any payload. What that does is because you're saying you don't have any payload, the null pointers going into XQSend and receive API are valid. That means when you are sending a binary semaphore, you're saying send some payload. Payload is 0, and that is okay because it's a 0-byte payload. XQ receive will typically receive data to a pointer, but because the payload is 0 size, I'm saying receive data to a null pointer, and that is okay only because the payload size is 0 here. I'm going to be very explicit in my code. So if somebody reads this code, they will see that, hey, this is very deliberate. Payload size is 0. I can be even more verbose in the code. Sometimes being verbose in the code like this is okay because you don't have to write and maintain comments. So you'll see that this program runs same way, accomplishes the same thing as our previous video. We received a binary semaphore signal. Also in previous video, we tried to send it 2 times or 3 times, and because it's a binary semaphore, we'll notice that we can't send the second signal because the consumer hasn't consumed it yet. So that's why we got this error statement, is it's not able to give the second one here because the queue is only 1 item deep. It's not able to put the second 0-byte signal because the consumer has not consumed and run this line of code yet. It's a different topic if the consumer is higher priority, so we're not going to go into that in this video. So let's do a video recap. Instead of creating a semaphore handle type, I created a queue handle and called it binary semaphore. To achieve the same effect, I created a queue of 1 item deep and 0-byte payload. X semaphore give becomes X queue send. X semaphore take becomes execute receive. Now, one last thing before we wrap up this video. What you will notice is if you go to semaphore.h API and you look for X semaphore create binary, you will notice that X semaphore create binary is actually just a queue create API. So FreeRTOS did exactly what we did. So they just gave an API an alias, and FreeRTOS, when you said X semaphore create binary, was actually creating a queue, one item deep, and I think one of these parameters will be 0 to indicate 0-byte payload. So FreeRTOS did achieve the same effect. And the reason why is they didn't want to invent new code when they could achieve the objectives of binary semaphore using a queue API. Thank you very much, and we'll cover more videos later.